Okay, geometry students, in this video we are going to start looking at angles, a definition of angles, their measures, a postulate about measures, and also different types of angles and how to name them. So we have a lot to look at today. I would like you to go ahead and get out your notes and your notebooks, and let's take some notes for a little bit. Please copy this heading in your notes if you would, please. I want you to copy down angles and their measures, lesson 1.6. Angles and their measures, lesson 1.6, and also include today's date if you would, please. Okay, let's continue on. Now, the first thing we need to do is look at the definition of an angle. I know that most of you know what an angle is, but we still need to give it a definition. So, I'd like you to copy this definition in your notes if you would, please. The definition of an angle is simply this: two rays that have the same endpoint. Isn't that simple? Two rays that have the same endpoint. Now, having said that, you are responsible for this definition on tests and quizzes, so please copy this in your notes. Now, when it says two rays that have the same endpoint, it simply means this. It means we have a ray going this way, and we have a ray going this way. There we go. And we say they have a common endpoint because of this right here, okay? And so here's a ray, here's its endpoint, here's a ray, here's its endpoint, and they meet, and thus we have an angle. Now an angle is simply, now listen to me, an angle is simply the measurement of the gap between these two rays right here, okay? Look, watch this carefully, please. If this ray were to move up and the space right here got bigger, then your angle just got bigger. And now it's almost 90 degrees, okay? Let's see if the angle went all the way to here. Well, now the space is really big. To me, that looks like about, I don't know, 140 degrees, okay? And you should know from many years of mathematics that this right here would be 90 degrees because you have like an L shape right here. This would be 90 degrees, okay? So you need to know the definition of an angle, and I wanted to give you a picture of it, okay, just so you understand what we're talking about. Let's continue on. Now, I want to talk about the parts of an angle, and I need you to take some really good notes on this, okay? So please copy this angle in your notes if you would, please. And let me fix this so it's not so big. And please copy this in your notes if you would. All right, and here we go. First of all, the point right here where the two rays meet, the common endpoint, that's called the vertex of an angle. Would you please make note of that? You need to know that, okay? That is called the vertex, V-E-R-T-E-X, of the angle. You need to know that. Now, this inside space right here that I'm coloring in, right in here, that's called the interior of the angle. And I would like you to write that down if you would, please. That's called the interior of the angle. Now, all of the space on the outside of the angle, actually it's anywhere that's not the interior of the angle, we call that the exterior part. The exterior part of an angle, okay? Now, while we're talking about that, listen to me. Sometimes the interior part of an angle will be rather large. I mean, if your angle looks like this, a really big angle like that, then obviously the interior part would be all the space in here that continues all the way out, okay? And the exterior part of the angle would be this outside part of the angle over here. So you need to know those three parts. It's very important that you know those parts. So when we talk about the vertex of an angle, or the interior part of an angle, or the exterior part of an angle, you know what we're talking about, okay? That's really important. And then also you should understand, it's pretty obvious that, let me see if I can get rid of this real quick. You should also understand that an angle is made up of two rays. So we would call this line right here a ray, and we would call this line right here a ray. So please understand those things about the part of an angle. Now let's also talk about how to name angles, and this is so important. Students, please listen to me. If you don't know what angle I'm referring to when I say something like angle ABC or angle BCD, you're going to be confused. So I want you to take some really good notes now on how to name angles, okay? Go ahead with your notes, and I want you to draw an angle that looks like this, okay? Draw an angle that looks like this. And I want you to put a point here, and put a point here, and put a point here. And we're going to call this S, and we're going to call this B, and we're going to call this X for no certain reason, okay? Now, I want you to learn how to give this angle a name. Please listen to me carefully and take some notes. First of all, we can call this angle. This is an angle symbol right here, so get used to that. That little symbol there means angle, okay? So we could call this angle SBX. Please write that down. Or we could call this angle XBS. Do you notice how the vertex of the angle is always in the middle of the three letters? Do you see that okay? That has to happen. You could not call this angle BSX. That's wrong. The vertex of the angle, in this case B, has to go in the middle of your three letters. Okay, I hope you see that okay. Now there's actually a third way to name this angle, and please write this down. We could also call this angle B, and that's acceptable. If you just want to use the vertex, you can. So we can call this angle SBX, or angle XBS, or angle B. Now, I need to show you something that's really important, so please listen carefully. When I say to you, we can call this angle B, that's not always allowed. If I had another ray right here, like that, now don't draw this in your notes. If you did, go ahead and erase. I don't want you to put this in your notes, okay? We'll get into this later, but I want to show you something. Please watch this. Let's call this C. If I said to you angle B, you wouldn't know what angle I'm talking about. Would Mr. Earhart be referring to this angle here? Or if I said angle B, would I be referring to this angle here? We don't know. So you cannot always use one letter to name an angle. So you're probably saying, well, when can we use one letter to name an angle? When there's no confusion. Look, right now, if you said, Mr. Earhart, look at angle B, I wouldn't know if you meant this angle or this angle down here. Okay? However, earlier, when we did not have this middle ray like this, I can definitely say angle B. If you said to me, Mr. Earhart, look at angle B, I would know that you're referring to this angle here. So it's okay to use one letter when there's no confusion. Other than that, you're not going to be able to do that, okay? So with that in mind, now I'd like you to go ahead and draw something else into your notes, if you would, please. I would like you to draw an angle like this. Please take some really good notes, if you would. Draw an angle like that, put a little arrow on it, little arrow. And I messed that up, didn't I? There we go. Well, that's good enough. And now I want you to draw a ray coming out like this. And let's just quickly put some letters up here. We're going to call this A, B, C, and E. You thought I was going to say D, didn't you? E. Now, if I asked you to name all of the angles that you see, please take some good notes. Let's call this angle 1, put a little 1 there. We're going to call this angle 2, if you would, please. And now, I would like you to name angle 1. Are you ready? Now watch, I'm going to use my red marker here. Here's angle 1. It comes down like this, hits right here, and then it comes over here. There's angle 1. Do you see it okay? So what would I call that? I would call it angle AEB. That's one name. Do you see it okay? Or I could call it angle BEA. Both of those are acceptable. I could not call it angle E, because if you said angle E, I would not know if you're referring to angle 1 or angle 2. Okay, so there we named angle 1. Now let's give angle 2 a name. Now here's angle 2. Comes down to here and then over to here. Everybody see that okay? That's angle 2. So let's give angle 2 a name. Now you could call angle 2 either one of these two names. You could call it angle BEC, or you could call it angle CEB. Either way is fine. So take some really good notes on this. Now, at the beginning of this activity, I said students were going to name all three angles. And you're probably thinking, Mr. Earhart, you're seeing things. There's only two angles, one here and one here. No, that's not true. There's also a really big angle that goes from here all the way to here. Okay? And so with that in mind, we can call that really big angle. I'm going to highlight it in green for you. There's also a really big angle, and it comes down like this from A to E and then over to C. There it is. So we could call the green angle angle AEC would be acceptable, or we could call the green angle angle CEA, which would also be acceptable. You could not call it angle E, okay, because that would be confusing. I would not know which angle you're talking about. So there we go. We named we named all three angles, and we gave each one two names, okay? And either one of those two names would be acceptable for each one. Okay, I hope that makes sense. Let's continue on. Let me grab a drink here real quick. Okay, let's take what we have learned so far and apply it to some problems, okay? So you can work ahead or you can watch me, whatever you prefer doing. Please copy this in your notes. Please copy this in your notes. I want us to name all three angles, and I'm going to give them numbers. We're going to put a little 1 right here, so put a little 1 right there, and we're going to put a little 2 right here. So quickly copy this in your notes, and you can work ahead or you can watch me. It's up to you. Here's angle number 1. I'm going to highlight it in green, and I'm going to give angle 1 a name. Okay, so here we go. Angle 1 can be called angle PQS. Again, you can work ahead or you can watch me, or we can call angle 1 angle SQP. PQS or SQP. All right, let's switch colors. Let's take a look at angle number 2. I'm highlighting it in red for you. There's angle number 2 right there. Let's give angle 2 a couple names, okay? You're welcome to call it angle SQR, or angle RQS. Either way is fine. It doesn't matter which one. Okay? And now lastly, let's give this really big angle from P to Q to R. Let's give that a name, okay? And we're going to call that angle PQR, or we can call it angle RQP. Okay, I hope that helps. This is not a waste of time. You really, really, really have to know how to name your angles, or you're going to be confused on tests and quizzes. Okay, let's continue on. Now, I want you to give 3 names for this one angle. You can work ahead or watch me. I want you to give 3 names for this angle. All right, so here we go. One name that I could give this angle would be angle RST. Another name that I could give this angle would be angle TSR. Notice S has to be in the middle of both of these names. Now, I can also call this angle S, because there's no confusion about which angle I'm talking about when I say angle S. So, all 3 of these names are names that you could give this angle. Okay, I hope this is making sense. Please take some really good notes on this, and let's continue on. Now, I don't want to be known as a boring teacher, but I would rather bore you than lose you. So, on your own, I want you to pause the video, and I want you to name all 3 angles that are shown to the right. So go ahead and pause the video at this time. Let's call this angle 1. Let's call this angle 2. And I want you to go ahead and name all 3 angles. Okay, hopefully you're done. I'm going to go pretty fast. Angle 1 is right here, highlighted in blue. And so for angle 1, you could have called angle 1 angle GJC or angle CJG. Now let's take a look at angle 2. I've highlighted it in blue for you right here. There it is. And so you could call angle 2, you could call it angle CJF, or you could call it angle FJC. All right, and then the big angle right here, I've highlighted it in blue for you right here, the big angle. You could have called that angle GJF, or you could call it angle FJG. I hope you're doing okay on this. Okay, let's continue on. Now let's take a look at measuring angles. I'm going to give you a couple of angles and I want you to use your protractor to find the angles measure. So at this time, I want you to go ahead and get out your protractors. Okay, now they should look like this. If you're not sure what a protractor looks like, it should look like this. Now there's different kinds. Some of you might have a hole right here and like a little line going across. Some of yours might have the little slide thing that comes out like this, a piece of plastic, and it rotates around the protractor. All of that's fine, okay? But this is what your protractor should look like. So go ahead and get your protractor out, and we're going to look at measuring some different angles. I'm only going to do a couple for you, okay? Just a couple, and then I'm going to turn you loose when we're done with the video. You're going to have homework, of course, in which you'll practice doing this, all right? So go ahead and get your protractors out. And now in your notes, I'd like you to draw an angle that looks approximately like this angle here, okay? So go ahead and do that now if you would, please. Go ahead and get out your notes. Well, you should have your notes out, but go ahead and draw an angle that looks approximately like this, okay? Now, please listen to me carefully. And the supervising teacher might need to pause the video and walk around the room and make sure everyone understands where to place your protractor, okay? Because if you don't place your protractor in the correct place, then you're going to have problems. And let me start off by saying this. Please listen to me carefully. If your angle is turned a little bit, let me show you what I mean real quick here. If your angle is turned like this on a test or a quiz, then you might want to take the sheet of paper and turn it back. Okay, turn your paper so that your angle has one line going across the page like this, horizontally, because it's really difficult to measure an angle that looks like this. You probably would want to take your entire sheet of paper that has this angle and then take your sheet of paper, didn't mean to do that, do this, and let's do this. You would probably want to take your entire sheet of paper and turn your paper so that the angle is going across like that, okay? Just my words of advice from me. I think that would be helpful, okay? All right, having said that, let's continue on. Now, I want you to take your protractor. You should have drawn an angle by now that looks like this. And I want you to pick up your protractor, and now listen to me carefully. For this kind of protractor right here that I'm shaking, you want to take this line right here. I've got a line right here, and I'm going to put that vertex of the angle right there. Okay, it's real important that I do that. So watch how I do this. I put that point right there on the vertex, okay? Now notice I have the vertex, that little line coming down right there. I have the vertex right there, and I have the bottom ray lined up so it goes right across this piece of plastic, okay? Now, everyone needs to, we need to pause the video, and the teacher needs to go around the room and make sure everyone knows how to line up their protractor correctly, okay? Now, did you notice that really I'm not very happy with how far this ray right here goes? It's not going out far enough. I'd really like it to go further. So sometimes you might need to pick up your protractor like this, and you might need to turn it, okay? And I'm doing the best I can here. You might need to turn it and take a straight edge and extend your angle so that it goes longer like this, okay? That's a very good thing to do, to be honest with you, because watch, when you do that, now look what happens. I'm going to go put my protractor back in place here, like this. Now, do you see how your angle that you extended, this ray that you extended, do you see how it goes all the way out here to your numbers? That's really, really helpful. So always make sure that you extend one of your rays with a straight edge. Use a straight edge so that it's not sloppy like mine is, and so that it comes out to here like this. Okay, that's really, really, really important. Okay, now I'm going to take my angle here and I'm going to extend this. So give me a second to do that. Here we go. Okay, very good. Now, would you please look at these numbers right here? 0, 10, please pay attention. Watch this, students. 0, 10, 20, 30, 40, and then it goes, see the little tick marks here, 41, 42, 43, 44, 45. So my angle is falling right on 45. So I'm going to write that number off to the side. But then look, there's another set of numbers here. Look, here's 180, 170, 160, 150, 140. Here's 130. It's right in the middle of 130 and 140. So I'm going to put 135. So here's my question. Which one of those two numbers, 45 degrees or 135 degrees, is the correct answer? It's only one of those. Well, let me tell you now, and go ahead and take notes on this, please. It's going to be the 45-degree angle, not the 135. Now, please let me show you why. Please watch carefully, students. And some of you know why already. That's fine. Others of you don't. So please be patient with those who are a little confused. Students, would you please think about this? If the angle was straight up, it would be 90, correct? And if the angle was opened even further, that would be bigger than 90. So think about it. If this is 90 right here, like this, and then I make the opening right here, this opening right here, if I make that opening smaller like this, if I make it smaller like this, there's no way the answer is going to be 135 degrees. I just made the angle smaller than 90. So it's going to be 45 degrees, not 135 degrees. And one of the main areas that students get confused is knowing which number to use. Do they use the 50 or the 130? Do they use the 70 or the 110? And you have to always ask yourself, is the angle bigger than 90 or smaller than 90? Okay, let's take a look at one more example and then we're going to move on. Okay, in your notes, I would like you to draw another angle and just make it look approximately like this. It's not going to be exactly like mine, but just make it approximately. That looks good right there. Okay, so remember, since we're not all using the exact same angle, then you might get out a little different measurement than what I'm getting, and that's totally fine, okay? Not a big deal. All right, here's the angle I would like you to measure, so you can work ahead or you can watch me, all right? First of all, remember that if this entire angle was turned, you would want to turn the angle back so that you have a line that's going across like this here. Okay, that's really, really important. Now, secondly, remember, sometimes when you put your protractor on top of this bottom ray like this, sometimes you have to extend this angle, so please don't forget to do that, okay, and do it very neatly with a straight edge. Even though I'm not doing that, you need to use a straight edge and extend it, okay? And I think that's just about right there. Now, let's take a look at where this angle is. Notice it's between 50 and 60. So 51, 52, 53. Looks like 53 degrees is one option. Now the other option is between 130 and 120. So we're looking at 120, 125, 126, 127. Okay? Do you see what I did there? It's between 120 and 130. So I guess you could start at 130 and count backwards. It would be 130, 129, 128, 127. Okay, so there's my two options. Now, again, one of the main mistakes that students make is they're confused about which number they should use. Well, ask yourself this question. If the angle was 90 degrees, sorry about that, students, let me fix that real quick. If the angle is 90 degrees, like this, have I made the angle smaller or have I made the angle bigger? Well, the answer is bigger. So there's no way that the measurement of this angle right here is going to be 53 degrees. It's going to be 127. Make sure you know how to measure angles. That's really, really, really important. And by the way, how about this? What if I asked you to draw an angle? Please pay attention on this, okay, students? You might want to go ahead and put this in your notes, okay? What if I asked you to draw an angle that was 78 degrees? Okay, well, watch carefully, please. The first thing you would do is you would draw a bottom ray like this, and then you would pick up your protractor and put it right here. I'm going to go ahead and put a point on this. We have a point right here. You would pick up your protractor and put it right here. And then remember, you want 78 degrees. So you would take your pen and put a little mark right here. 30, 40, 50, 60. Here's 65, 66, 67, 68 is right here. Okay, so you put a little mark there, and then you can move your protractor out of the way, and then simply go ahead and draw the rest of your angle. And of course, I'm going to fix mine so it's a little better, but you get the idea. Okay, so there we go. That would be an angle that measures 78 degrees. So if you need to practice some of these on your own, that's totally fine, but make sure you know how to measure angles and make sure that you know how to draw angles also. Okay, let's continue on. I want to give you some very quick definitions you need to copy in your notes, and they are very, very important, and you're responsible for all of these on future tests and quizzes. So please copy this in your notes. Congruent angles. What are congruent angles? They're angles that have the same measure. Okay? So if angle A was 30 degrees, angle A equals 30 degrees, and angle B equals 30 degrees. If they both have the same measurement, then I can say that angle A is congruent to angle B. Now notice this congruent symbol. Make sure you know how to draw that. It's an equal sign with a little squiggly mark on top of it, okay? And so whenever two angles, and all of this stuff that I'm writing here, students, if you're taking really good notes, I would encourage you to write this down. I would not only write the words down, I would also write down the examples that I give you, okay? So if angles are congruent, that simply means they have the same measurement. So if two angles have the same measurement, like these two angles do, then we can also say they're congruent. You need to know this. It's very important. Please copy this in your notes. Acute angle. What is an acute angle? Well, it's any angle that is less than 90. An angle that is less than 90. So any angle that has a measurement smaller than 90 is acute angle. We call that an acute angle. That's pretty simple. What is an obtuse angle? An obtuse angle, well, it's an angle that is larger than 90. So any angle that is larger than 90 is an obtuse angle. You need to know all of these definitions for upcoming tests and quizzes, okay? Let's continue on. A right angle is an angle that measures 90 degrees, and we should know that by now. We're juniors or sophomores in high school, okay? That would be not the best drawn, but that would be a right angle. A right angle has the shape of an L, okay? So a right angle is an angle that measures 90 degrees. Here's one that might be new. Copy this in your notes, please. Straight angle. What is a straight angle? It's an angle that is a straight line, and it always measures 180. Let me show you what I mean. We'll start right here with your vertex. Okay? Put a point here, and then we're going to go this way. And then, of course, we have to move this up a little bit. So what we have is this. We have a ray that's going directly to the right and a ray that's going directly to the left. And so we would call this angle right here a straight angle, and it has a measure of 180 degrees. You need to know that. That is called a straight angle. You have a ray going to the right and a ray going to the left. Or a straight angle could look like this. A straight angle could be going down this way. And then let's put a point right here. We'll put a point right here. That would be a straight angle. You have a ray going this direction and a ray going the complete opposite direction. this would be a straight angle, and it measures 180 degrees. You need to know that, okay? So please note all of these terms and definitions. Please write these in your notes, and hopefully you've written down the examples that I've given you. You need to know these on tests and quizzes, okay? Let's continue on. I would like you to categorize these three angles. Okay, let's put them in a category. So copy these down, take some really good notes on this. The measure of 30 degrees. Well, we would call that a what angle? It's less than 90, right? So we call that an acute angle. This angle B has a measurement of 90 degrees. Well, any angle that has a measurement of 90 degrees, we call that a what type of angle? A right angle. Please copy that down. And I'm not sure why I did not include the 1 here. There should be a 1 here for 145 degrees. So the measure of angle C is 145 degrees. Well, we would categorize that or classify that angle as an obtuse angle, because any angle that is larger than 90 is going to be an obtuse angle, with the exception, of course, of a straight angle. A straight angle is 180 degrees. Okay, so this would be an acute angle, this would be a right angle, and this would be an obtuse angle. Okay, take some good notes on this. Let's continue on. Now let's take a look at a postulate. It's going to sound really confusing, I want to warn you, and I want you to copy it down and just relax, don't worry about it, and then I'll explain to you really well what the postulate means. Okay, here it is. This is called the angle addition postulate, and it reads as follows. If P is in the interior, or the inside or the interior of angle RST, then the measure of angle RST is the sum of the measures of angles RSP and PST. Now, to me, that sounds really confusing, but I'm going to show you what this means with the picture, and I think you're going to totally understand it. So here we go. Copy this down, please. By the way, you do need to know this for future tests and quizzes. Okay, so copy that in your notes. And now copy down this picture. This is going to help you a lot. Notice it says this: if P is in the interior of angle RST. So let's go ahead and draw angle RST. Everybody see that okay? And it says P is in the interior. So I'm going to put P right here. Okay, and let's go ahead and draw a ray, because we're going to need one in just a second anyway. So go ahead and draw a ray that goes through point P. Do you see what I've done there? Now look what it says. It says if you add up this angle here, RSP, we're going to call that angle 1. You might want to put a little angle 1 right there and then put a 1 right here. And angle PST, angle PST. And we're going to call that angle number 2. So we're going to put angle 2 right here. If you add those two angles together, you will get the entire big angle of angle RST. Well, students, that really should make sense. I mean, think about it. Let's pretend this angle right here, angle 1, is 20 degrees. Okay, just pretend. And let's pretend this angle here is, I don't know, 30 degrees. If from here to here is 20 degrees and from here to here is 30 degrees, then this whole angle across has to be what? 50 degrees. Doesn't that make sense? It really should. Look at another example. Copy this in your notes if you would. I want you to draw a right angle in your notes, okay? Now, if I draw a ray that cuts 90 right in half, although obviously that was not a very good example, but that's pretty good right there. Think about that for a second, students. This is not easy to see. If I have a whole angle here, it's 90 degrees, and I cut it in half, then this angle right here would be how much? 45, and this angle right here would be 45. In other words, let's call this angle 1, and we'll call this angle 2. If I add angle 1 and I add angle 2 together, 45 plus 45 degrees, I'm going to get 90 degrees. And that's all that this postulate is saying. It's just saying when you have an angle with a ray inside the angle, if you add these two angles together, they're going to give you the entire angle. And to me, that's pretty simple, okay? So I hope that clarifies it. It makes it a little easier to understand. If you're still a little foggy, we're going to work some problems here in a second that I think will help you understand this a little better. So let's take this postulate and apply it to some problems. So here we go. Copy this problem in your notes if you would, please. I want you to draw angle PTM. Go ahead and do that now, please. And then draw this ray in the middle, ray TN. Okay? And I want you to call this angle here 30 degrees. And I want you to call this angle right here 40 degrees. I shouldn't say call this angle. Let me rephrase that. I want you to put the measurement of angle PTN is 30 degrees, and the measurement of angle NTM is 40 degrees. Okay? All right, let's continue on. I want you to find the measure. I'm going to highlight it for you. I want you to find the measure of angle MTP. That whole angle right there. Well, students, that really shouldn't be too difficult for you to do. Let's think this through. If the space from here to here is 30 degrees, and the space from here to here is 40 degrees, then the entire space from here all the way down to here would be what? Would it not be 70 degrees? Because you simply take this angle here and this angle here and you add them together and you get the whole angle. And that's what the angle addition postulate is all about. Okay, let's try another problem. I want you to find, go ahead and copy this in your notes if you would, please. I want you to copy an angle that looks like this. We're going to call it angle DBA. And then I want you to draw a ray that's pretty much going straight up in the air, and we're going to call that ray BC. Okay? Ray BC. And I want you to find the measure of ABC. Now, students, I need you to really, really listen carefully, okay? Do you see this 60 degrees right here? Everybody see that? Let me make this a little bigger. I want there to be no confusion as to what we're doing. Just ignore. I guess we can move this blob down here. There we go. All right. I want to make this a little bigger so we see this, if I can do that. I'm having a really bad day. There we go. All right. Now, okay. Now, do you see the 60 degrees right here? Please listen to me, students. That refers to this angle right here. Right there. And you probably knew that. So that little angle right here is 60 degrees. However, you're probably thinking the 135 degrees is referring to this angle right here. And it's not. And the reason I know that is for this reason. Notice how the 135 is in what color? Red. And notice how this line in red goes from here all the way across. So what they're saying to you is this. They're saying this little angle right here is 60 degrees, and they're saying to you this entire angle from here to here all the way across, the entire angle is 135. And look what they want you to find. I want you to find the measure of angle ABC. So here's the angle we're looking for. Here's A, here's B, and then here's C going up. So they want you to find the measure of this little angle right here. Now guys, think about that. You have to think of a number that you're going to put right here. That 60 plus that number would give you 135. And would it not be 75 degrees? Think about it. If I have this little angle from here to here is 60, and this little angle from here to here is 75, then the entire angle from here all the way to here has to be 135. Another way to do that is simply take the bigger angle, which is 135 degrees, and subtract from it 60. And if you do that, either using your head or using a calculator, either way is fine, you will get 75 degrees. And so in this case back here, I gave you two smaller angles and you added them together to find the bigger angle. In this example, I gave you the measurement of the bigger angle. The bigger angle was 135, and I gave you the measurement of one of the smaller angles. And so you took the bigger angle and you subtracted out 60 degrees, and you found the smaller angle, which is 75 degrees. Okay, I hope that makes sense. That is, once again, using the angle addition postulate. Okay. All right, let's continue on. Actually, that's it for today. So that's it. I hope this video has been a help to you. If you have any questions on this, maybe you want to rewatch it, or call or email if you have any questions.